welcome to this video for the graphic organizer for projectile motion keywords. So this is to help you when answering some real-life application problems of quadratic equations. So we have our organizer here, and there's some important points. Really, the most important points are these three. If you can get those 3 points, you can answer the majority of the questions, and we can use Desmos to get every one of those. So you're going to need Desmos for the notes portion, but not for your graphic organizer. So let's take a look. This point, so if we take a look, we have an axis here and in here. This is our x-axis, and this is our y-axis. So this point is on the y-axis. It's called the Y-Intercept. I'm going to abbreviate it Y-Int, or intercept. When we have some real-world problems, the Y-intercept will represent the starting height of whatever the object is, and often the question will be, how high off the ground did the object start? And so that's the Y-intercept. It was on the ground. It started at 0 feet high. It was 100 feet in the air, so it was 100 feet high. It's the starting height of the object, and you can tell the Y-intercept just from the equation. If it's in standard form, the Y-intercept is the C value when you're in standard form. So you could tell the Y-intercept just by looking at a standard form equation. If you can't tell, you can look at the table of values. Once you put it into Desmos, and it's where x equals 0. So you'll just look at the y value for where x equals 0, and that will also tell you your Y-intercept. Another very important point, we've talked about it a lot, is this turning around point. That's called the vertex. So our vertex tells us a couple things. Very often, our graph is talking about it's either time or distance, and so a lot of times the time is in seconds, but every problem will be different. So this is either time or distance for our x values, and then our y values are very often height. It's almost always height. How high off the ground? That's why this is saying how high off the ground did the object start, because it's the y values talk about height. So when we're talking about the vertex, questions that you'll get are very often, what is the max height of the object? If they're asking what is the max height, that's just like when I ask the characteristics, what is a maximum? It's talking about the y value of the vertex. Other questions it could ask, when does the object start to come back down? So imagine if you kicked a ball, it went up, and at the vertex it turns around and starts to come back down. When it comes back down is not talking about the height. That's talking about a time or a distance, depending on what your x value is. So that would be talking about the x value of the vertex. So when does the object come back down, start to come back down? And when it asks that question, that is the x value of the vertex. That same question could be like, how long until max height? Or when will the object be at max height? Just different ways the same question can be asked. But when we're talking about that, those are all referring to the vertex, and some of them are referring to the y value, and some of them are referring to the x value. Now, these next 2 points, they are both x-intercepts. But this x-intercept is not part of the real world. The real world is in the first quadrant. So while this is an x-intercept, if the left-hand one is past the origin, we're going to ignore it if it's negative. So ignore if negative, because that's not real world. Okay, so that x-intercept gets ignored a lot. If it's here at the origin or on the right into the first quadrant, we'll pay attention to it. But when it's over here in negative world, we don't pay any attention to it. Now, this x-intercept gets used all the time. So this is the other x-intercept. So there's two ways we can find this. You can either use Desmos to find out what this number is, or you can use the quadratic formula. That takes a lot longer. It's easier to use Desmos. Okay. The kind of questions, so the x-intercept will answer questions like how long the object was in the air or when does the object hit the ground. How long was the object in the air, or when does the object hit the ground? Those are the three most important points. Those will answer the majority of the questions. There's a couple other things that can come up, and we'll deal with those in the notes. So those are the points. Now we got to talk about domain and range. So I'm going to use a lot of colors here to kind of help you envision. Domain talks about what x values are part of the scenario that we're talking about. So remember, we're only in the real world, so we're talking about x values that start at 0 and go to the x-intercept. That's the only x values that would be part of this graph. So this is our domain. Okay. And your x value right here is 0. So the domain will be from 0, and then we've used this notation before, so we'll say less than or equal to x, because we are talking about domain, and domain is x values, which is less than or equal to whatever this x-intercept is. Whatever that point is, that the x value of this point, that's going to be the ending of the domain. Okay, so that's our domain. Our range, remember range is a y value, and it's talking about height. Oh wait, so I'm going to turn this so it's a little easier for me to draw a straight line. So your range is going to go from the ground straight up to the vertex. Okay, so from the ground straight up to your vertex, that's going to be your range. Alright, so let me turn this so it's a little easier to write this. So this is our range. Range talks about y values. Your lowest y value will be here. All y's are 0 at the ground. Less than or equal to y, because it is range, is less than or equal to, and it stops at the vertex, so it stops at the y value of the vertex, whatever that number is. So that's what our range is going to be. So these real world problems have restricted domains and ranges. So we have to pay attention to what can actually occur. There's two more things that I want to tell you. Those are our intervals of increase and decrease. So I'm going to turn it back this way for a second. So starting here at the Y-intercept, because that's where our real world starts, all the way up here to the vertex. Now notice, if you're traveling from left to right, which is how we read our graphs, when you get to this point, you're going up the graph. That makes this an interval of increase. Okay, so this is an interval of increase. Okay, when you're naming this interval of increase, it starts at this Y-intercept, and so we're always using X values for our intervals of increase and decrease. So the X value at the Y-intercept is from 0, is less than or equal to X, because we're talking about X values, and we stopped going up at the vertex. That's when it starts going down. So we're going to put the X value, it's going to stop at the X value of the vertex. So our interval of increase will be from 0 to the X value of the vertex. Now we just said at the vertex we were going up, and now it starts going down. So from the vertex all the way down to the ground. If we're traveling from left to right, we're now going down the hill. So that's a decrease. So this is an interval of decrease. Let's turn it so we can see this a little bit better. Interval of decrease. So our interval of decrease, it's the graph starts going down at the vertex. So it goes from the X value of the vertex, and we are talking about X's, so we're going to put that in the middle, and it stops going down when it hits the ground. Well, that point is the X-intercept. So your interval of decrease will be from the X value of the vertex to the X-intercept, because that's when the activity stops. All right, so this will help you when you're working through our real-world problems. I encourage you to have it. I encourage you to label all of your points, because it will make naming domains and ranges much, much easier in your intervals of increase and decrease. Hopefully that was helpful. Let me know if you have any questions. See you in class.